Yesterday we discussed about indexes. Indexes are used to search the data faster, find the data faster, right? And there are two types of indexes, cluster index and non-cluster index. There can be only one cluster index in a table. Usually it is created on the ID columns, or if you create a primary key, automatic cluster index gets created. If you create any constraint, automatically unique non-cluster gets created. That is another type, non-cluster index. But we can have multiple non-cluster indexes in a table. If you have created unique constraint, no need to create any non-cluster index because it creates automatically on those columns. On top of it, if you want to create any non-cluster index, you can still create. I've shown the syntax and I have shown how to create also. What happens if you don't have index? You are looking for data. What happens if you are not having index? It is going to do whole table search. That is called as table scan. It is going to scan whole table and try to find out where your value is there. It takes a lot of time. With the help of index, the values are ordered, so the search will be faster. And these indexes are works on B tree, that is balanced tree. I explain you what is balanced tree, how it works. Where is this? Where here? So if you see here, this is the balanced tree. How it works. If it is a cluster index, the leaf nodes will have the actual data. If it's a non-cluster index, the leaf nodes will have address of the data. Correct? This is what we discussed yesterday. And next, cluster index gives faster performance than non-cluster index because in that there won't be ideally no duplicates. Ideally means whenever you work with primary key. Okay. So and in a table only one cluster index. You cannot create multiple non-cluster indexes. As it's a one cluster index, the data gets primarily sorted on that particular column. So the search will be faster. So advantages I already told, faster search and improves the performance while searching. Both are one and same, you can say. So I told this after inserting a lot of data, it's suggested to do a rebuild and reorganize the indexes. When you are inserting more data, disable the indexes or drop the indexes and create the indexes after insertion. Generally, we do this before ETL. You are loading ETL, I mean, using ETL. Using ETL, you are loading data to table which has indexes. So in the ETL itself, before the data flow task, what you do is you disable the indexes. You write the scripts to disable the indexes or drop the indexes. And after the after data loading is done, then write execute SQL task to create the indexes. Okay. So two execute SQLs you create before the load and after the load to drop the index or disable the index before the load and create the index after the load. Okay. If you are disabling the index, then you have to uh, uh, disable the index, do the ETL load, data flow task, and then you have to enable the index. At the same time, you have to write the command to rebuild the index. Okay. How to write the command to rebuild index? Don't worry. You just need to right click here. You'll have an option. Oh, this is not going to show. It is showing C. Do you want to rebuild? Just click on script. It will show how to rebuild the index. Okay. Alter index on table, rebuild all this. Okay. Even this is also fine. Even if you write till is also fine. Even till rebuild is also fine. No need to write all this. Similarly, organize, reorganize. Reorganize is also same. So for every index, whatever you created, you have to create, you have to disable the index also, right? So disable. For this also you take a script. So before creating the, before loading the data, for data flow task, for all the indexes, you disable it. So you disable the index, all the indexes like this. And after data flow task, you are going to rebuild all the indexes and then reorganize all the indexes so that after loading huge volume of data, your indexes perform better. This is one option. Or first drop the indexes, all indexes, drop index name on so and so table, drop index name on so and so table. You write all the drop indexes, do the data flow task, and next create the indexes. So this is one data flow task. This is execute SQL task. This is data flow task. This is execute SQL task. Same here also. Execute SQL task, data flow task to load the data, and then execute SQL task. Are you clear on this?
So can you explain once time this before from the rebuild? Yeah, from the rebuilding, how to do that?
Rebuild is what it will do. Rebuild is going to reset the data. Rebuild is generally used to check any data issues. Reorganize is used to order your data properly so that your index works correctly. Search will be faster. So it's like this. It's like this. So you have a book. Okay, you have a book. So there is an index already. You have a book and there is an index already. Now for this book, there are 100 pages added. So what 100 pages added is a new version of book, okay? 100 so the first 100 pages are there, 100 pages got added. So these 100 pages are part of this 100 pages in between, or after that also, few after that also. In that case, your content also, the index content also should be changed, sir, no?
Yes,
It
sir.
has to reorganize. So there is a chapter here. I mean, there is a chapter here. There is a chapter here under the same unit. So there should be a new. There is a new chapter here added. Okay. So it has to be rebuilt and reorganized. This is
Yeah,
called
we
as
have to. Yeah.
reorganizing. That is called as reorganizing. Data will be reorganized accordingly. Okay. Rebuild is to check any errors in the data, any other errors. Build means verify errors. If you see SSIS also, you will find this rebuild build. You know, have you checked any time? No. Yes.
No, sir.
No, sir.
So this is my project. If you see on project, you have an option build rebuild. What is build rebuild? First time you are doing build, check for errors. Okay. Second time you can do rebuild. Rebuild means no need to do everything verification. Based on the latest changes, after the rebuild, what are the changes you can test for those. Okay. Clear?
Okay,
So
sir.
rebuild is going to check any issues are there.
Okay, sir.
Explore all the options in your SSIS. Okay. See, you'll get errors. What are all errors are there? No need to execute this and find the errors. If you have any errors, it will show like this. Okay. Okay. So moving on, we discussed about rebuild, reorganize. Next is difference between scan and seek. So scan, all the rows from the table are scanned. Seek, selective rows are seek. Seek in sense what you are looking for. Okay. One moment. So what is scan? Scan is nothing but look for all the rows in the table. Seek means look for something from the table, not everything. Okay. You getting?
Yeah.
So scan is going to read every part of the table. Scan is going to read every part of the table. Seek is going to read some part of the table. That is why it is called as all the rows from the table, select 2 rows from the table. Got it?
Yes, sir.
Here, are you getting background sounds?
No.
No? Okay. Fine. Next, this is fetches. What fetches? It is going to fetch selective data from the table and all the rows from the table. Touches. Every single row of the table is either required or not. So it is going to verify or touch every single row of the data. It is required or not? It is required or not? It is required or not? It is going to touch. Yesterday I told you, right? You have 1 to 100. It is going to check this is. Okay. So here only required or matching row it is going to check, not all the data. It utilizes more CPU consumption and very less CPU consumption. More input output reads, less input output reads. Execute select statement, execute only where condition. Like, what is required, it is going to verify. Not all. It is like select star. It is like select star from with where condition. Are you clear about this? What is scan
Yes,
and
sir.
what is seek? It is selective operation. This is whole operation. Okay. Less performance. Sorry. Faster performance or faster retrieval, less IO, less memory consumption, whereas more IO consumption, more performance, more IO reads and memory consumption. What is the difference between table scan and table seek? There are chances that you will get this question. Okay. Table scan, index seek. What is the difference? So table scan, it is going to scan total table. Okay. When you are going to use an index scan, when we need to retrieve all the data, such as 90% to 100% of the data, if you want, use index scan. When you have less percentage of data retrieval, when you want to retrieve only small percentage of data, it will use index scan. Who are going to use? This system is going to use based on index we create. Okay. Where clause. The query doesn't have a where clause and the table doesn't have cluster index. Then it is going to use full table scan. Okay. Index seek. The query doesn't have a where clause and the table have a cluster index. Okay. Then index scan is used. What is this? Is not clear. Just a moment. I'll try to get it. Okay, you see, right? Table scan and index scan one and same. The table scan is slower than index. Why? Because the table scan will do whole search. Okay. Whereas index will only particularly point to the one whatever we are asking. No table scan. The scan is slower, seek is faster. Are you clear? I told already where.
Clear, sir.
So here we'll have a cluster index. Here we'll not have cluster index. Here you are going to apply index scan or table scan when you want to fetch whole data. Automatically apply this SQL Server engine. If you are pointing to fetch a smaller amount of data, then it is going to do an index scan. Okay. The query doesn't have a where clause and the table doesn't have a cluster index, then full table scan is used. Okay, when you are writing select star from table, then automatically table scan or index scan is applied. When you are writing with a where condition, then or with a group by condition or with selected columns, then automatically it is going to do indexing. Okay. Clear? Clear? Any questions?
No.
So that's we have one questions on the Here that difference between table scan, index scan, and index seek. That's we have to do index scan and table scan. Same thing.
We don't do the terminologies, no. So any topic you want me to repeat, or should
Yeah,
I go with the next one?
table scan and index scan.
Exception handling
Index
will do.
six, index six, I think we got maybe looking the specific data. Is that the index six?
I'm sorry, I don't know why it got. It is, closing and opening again. Yesterday I told you, right? You have the data like this. Okay, till 100. You have data like this till 100. So you are looking for some value 76. What you have to do? You are going to compare with each and every value. Correct? So this is table scan or index scan. Index scan, no need to say. Table scan you can say. Now index seek. What is index seek? Same values are there. 1, 2, 3, 4, and so on 100. Okay. You are looking for you are looking for 76. Okay. Because of this is having index, the data is organized in a B tree. How? Like this. 1 to 50. 51 to 100. And further. And further. And further. So finally what you'll have? Leaf nodes you'll have. Leaf nodes means 1, 2, 3, 4 till 100. So now I'm looking for 76. So it will go to here. So this is avoided. And it will go to so 51 to, okay, it will have 2. So again 76 will be part of this is 51 to 75. 76 to 100 it will go to here. So this is avoided. So 75% of data is avoided here. Then 76 to 100 it will go here. Again 76 to 82 is in one part and rest is another part. So here again this is avoiding. So it is finding 76 somewhere here. So it is finding the shortest path. It is looking on the selective data, not whole data. That is what index seek. Clear? Supriya?
Yes, clear. But table scan and index scan is the same then?
Yes. Table scan, index scan, on and same.
Ah.
Clear? Any questions?
There is the question on chat.
Okay. Where? I don't see. Can you please repost because I rejoined, right?
There is no question there.
Yeah, I don't.
Okay. Can you repost? Or who has posted the post again?
Sir, there is
Or,
no question in there.
okay. No questions from anyone?
No.
Okay. Did you write commands to create indexes? Yesterday you have written in the session, you remember? You will try later.
I have one question.
Yes, please.
So in real time, right?
Hmm.
Now we know the use of index, right? What is gonna work, is gonna work on. But when do we need to create the index? Like in what kind of requirement or in what kind of
Okay.
situation we
That is
need to?
part of your daily activity. Like it doesn't mean that you have to create indexes explicitly every day. Okay.
So wherever the performance is
See,
lagging.
whenever in real time, most of the tables will have primary key, correct?
Mhm.
It means that already cluster index is there.
Right.
And many columns will have, or many, not few columns will have unique constraints. So by default, unique non-cluster index is created. Okay. But
Right.
I told one scenario where I worked on some analysis, very big code, which was taking hours of data, 10 hours to execute. We made it to seconds to execute, correct?
Mhm.
So in that process, we created indexes. Okay. So you will get to create index when you have performance issues. When your data is retrieving very slowly, okay, we are going to do the analysis why the data is fetching slowly, what causing problem, where indexes create, where which indexes or no, where index can be created, how it is going to boost up the performance, all those things we are going to check. For sure, index will improve the performance. On top of it, we have to even model the data accordingly. Okay. So modeling plus index gives you the best output. If you have whole data in one table, like 200 columns or 250 columns or 300 columns, and you are creating 20 indexes on top of it, your performance, your query performance will not be faster. Okay. You have to create index on the columns which are really required and which are more used in the where conditions, more used in the join conditions, that is primary key, foreign key columns, or where conditions, group by columns, subquery columns, where it is being mostly used. Such columns, if you create, the data gets ordered on top of it so that the joining will be faster, retrieval will be faster, group by will be faster. Right? Agree?
Agree.
Yeah.
Yes, sir. Sir, I sent one question in the chat
Yeah, I
box.
see. There are 500 lines SQL statement written 2 years ago, and it
Yeah.
takes 2 minutes to execute. Now it takes more than 10 minutes to execute. How will you optimize it? So, remember the statement has select, insert, delete, update. Okay, alter. Alter maybe you can ignore. Why? Because alter is going to drop the table itself, or alter may be adding a column or dropping the column. So alter cannot impact the index. Which is going to impact indexes? Insert or select. Why? Because your insert is slow. If your insert is slow, it means indexes are there. Every time you write an index, every time you write an insert, it is automatically doing a reorganizing, or it is trying to organize the data after your insert. So second insert you are doing, again it is trying to reorganize. If you are inserting 100 rows at a time, it will be very slow. Insertions happen at the same time organizing happens. Okay, so that's why your inserts are slow. So what you have to do, I told already. Disable,
Yes,
insert,
sir.
enable. Okay, that is a solution.
Yeah.
If your
Yeah.
select is slow, if your select statement is slow, see, now these are the 500 lines or 1000 lines of code which you have written 2 years before, and data is 2 years old. Okay, you're getting me?
No, yes, sir.
2 years before, the data size is less. So your query worked very fastly. Today, the query size is more, the data size is more. When data size is more, retrieval will be fast, retrieval will be slower. Yes or no?
Yes, sir.
Correct.
Yeah.
So it's like I'll just tell a simple example in a different way. You have shifted your house to a new house. You bought a new house and you moved from rented house to own house, let's say. So on the day of shifting, what you'll do? You take everything into a lorry and you go and dump everything into one room in your new house. Mostly you dump everything into your new house in one corner on one side, one room, right?
Yes, sir.
Right. So now you shifted your house, you started your journey in a new house. Everything is dumped into one room. And the next day you want to identify or pick some object which is required. So how tough it is? It takes a lot of time to pick the data, yes or no?
Yes, sir. Yeah.
Just telling this is not the answer to the question. I'm just telling this. So it will take
Yeah.
a lot of time to pick. So after 1 week, day by day, every day, what you do is slowly you are organizing things. After 1 week, you have ordered properly what should be in living room, what should be in kitchen, what should be in bedroom, what should be in washroom. You have ordered your data properly. So how much time it will take after 1 week? It will be very easy. You'll get to know which area it is. So you are looking for a spoon, go to kitchen. If you are looking for a sofa, if you are looking for to wear a dress, go to bedroom and a wardrobe will have. Correct. So you have
Yeah.
organized your data. You know where the data is. It is easy to find, or at least you'll be searching in a small area of data than whole data. Correct.
Yeah.
Okay. So coming to question, the 500 lines of code were executing in 2 minutes, 2 years before. Okay. 2 years before, the data size is less. So it is able to execute in 2 minutes. Down the line, 2 years, it was slow. It was faster. Now, after 2 years, it is slower. Why? Because the same query is looking on bigger volume of data. Okay. Earlier, the same query looking for the smaller volume of data, it was faster. Now the data size has
Yeah.
increased. Obviously, the query will not work as expected or as required in 2 minutes. So what we had to do, we had to go through the query, see what select statement is having, what where conditions are there, what group by is available, joins are there, subqueries are there. Okay, what is the data? How many tables are joining? What are the indexes on this table? Okay. If indexes are there, okay, on what columns are there? How many IO rates? All these things we have. DBA actually does this mostly high level we do. Deep level analysis DBA do. So then you try to if the query is very big, try to separate that query into small pieces so that it will run faster, and find to run it faster which indexes will help, on which columns it will help. This cannot be explained like without seeing. This is kind of a case study which has to be implement. No, which takes time. It's a process, not like a simple answer. Okay,
Okay, sir. Yeah.
and there are multiple ways to resolve this. Okay,
Mm.
it depends on the data query and how we analyze on the at that particular time.
Okay, sir.
Questions, please.
Thank you, sir. Thank you, sir.
Bye-bye. Questions. Okay, so exception handling we discussed already. Set operators. Shall we discuss set operators?
Okay.
In this week, we discussed a lot of topics, I guess, correct? Triggers we discussed.
Yes,
And what else we discussed?
Yeah, but these are the theoretical topics, so
Right. What else we discussed? Remember, I forgot. We discussed about indexes, triggers. That's all, right? Yeah, that's all. So set operators. Do you remember set functions in a school mathematics?
yes, sir. Yeah.
Set functions. Set A, set B. 1, 2, 3, 3, 4, 5, 4, 5, 4, 5, 6, 7, 8. So A, A union B. Just give me a moment, please.
Yes,
What about
sir.
your union?
A and B.
A union B.
Yes, all
Okay.
data from the A and set A and
A
set
and
B.
B, A and B without duplicates. Okay. A union is A and B without duplicates. 1, 2, 3, 4, 5, 6, 7, 8 without duplicates. Okay. A intersection B is there. A intersection means which are only common. That is 4, 5. A except B. I think used to be like this, I guess. A except B. It means only in A but not in B. So only in A, what are there? 1, 2, 3. Similarly, B except A. Only in B but not A. 6, 7, 8. Only in B but not in A. Next, A, I forgot. Urinal, I guess. Urinal, like this we write. Urinal B. It means along with duplicates. 1, 2, 3, 4, 5, 4, 5, 6, 7, 8. This is in our school days. Try to recall. So we'll try to learn what is there in SQL and what are the rules. If you have learned merge join, merge transformation in SSIS, okay, similar rules are there here, or actually the rules are applied in SSIS based on SQL Server rules only. Okay, so let us see here. Set operators are used to combine the results from two or more tables, provided these are the rules to be followed. All the queries should have same number of columns. If you are combining the two tables, those queries should be of same number of columns. This is not join, this is set operations. So joins also used to combine based on a common column, but here set operators are used to combine based on same number of columns. There should be 10. If there are 5 columns in table 1, there should be 5 columns in table 2 also. If you are combining 10 tables, 10 tables should have same number of columns. And also the corresponding column should have the same data type. Let's say, just imagine Select employee ID, employee name, employee age from employee 1, let's say. Similarly, you have employee 2 table. So when you are combining these two, both queries should have the same number of columns. Example, employee. Same, both queries should have same number of columns. Okay. And also the corresponding columns should have the same data type. Integer, integer, varchar, integer. Else it will not work. That is the first rule. All the queries should have same number of columns and the corresponding columns should have the same data type. Okay. Now you are combining this. Let's say you are doing union or whatever the operator. You are writing set operation, union or intersect or except or union or whatever. So what is the header output? Output will have employee ID, employee name, employee age. The table output will be like this. These columns will not come. This data will get merged with this, and on top, whatever the query is there, those header only will be there in the output. Okay. Output columns or output heading in the result are based on the very first query used in the operation. And then if you want to sort the data, order by should be used at the end, not in the in between. So if you want to sort the data, you have to use at the end. Order by employee ID. So it gets sorted. So it is going to combine and then gets ordered based on the first column. You cannot write here order by. And if we say order by here also, I'll write. This is wrong. This is wrong. You cannot have order by clause in between set operations. Okay. You can have where, you can have group by, everything. But order should be at the end. Clear on these rules? Please go through these rules. I'll wait. These rules are very, very important. Go through those rules. Let me know. I'll wait.
Sir, can you explain rule 2 and 3 once again?
Rule 2 is very simple. It is not actually rule. When you are combining this, okay, the output we get, right? Query output. You get a query output, right? So the column headers will be the first column, first table or first query headers. Because it is going to combine this data and this data. Let's say this is a first table data. This is a second table data. Just imagine. So the data is combined into one set and the output will be based on the first query columns. That is what it is. The column heading in the output will be which is similar to the first query. Okay. That is second one. Clear?
So this is similar like to the join.
No.
No.
Join doesn't require all the columns to be same. All the corresponding columns should be have same. No. Join requires only one column to join.
Yeah. Okay, sir.
Prashant, you are saying
So-
something?
Yeah, so what you are saying is set operators consist of like, so we have union, right? Union, all, intersect, and except. Those are the part of set operators, right?
Correct.
Yeah, okay. So basically union is a kind of set operator. So union all is a kind of
Union is
set
a part
operator.
of set operators.
Yeah.
Union is one of the types of set operators.
Right. Okay. Yeah.
So you mean the first table column will only appear, right?
Not first column actually, first header.
First header for the first table.
Yeah, correct. Whatever is header used in the first query, that will be the output column. Header.
And what about the third rule?
No, data will come, but header will not come.
No, about the third rule, the rule number 3.
Rule, okay. So if you want to sort the data, because this is combining into one set, correct? The output is one set. Okay, you cannot write order by here. Syntax is wrong. If you are writing order by, it has to be at the end of all the set, all the operations, all the combining queries. At the end, you say which column you want to sort. I want to sort on the first column, employee ID. Second column, employee ID. Order by should be added at the end of your query. Okay. So that's the
So
rule.
what's the main purpose of the set operation? What does it do?
Yeah. So, merge transformation in SSIS? Merge transformation.
I didn't get you what?
In SSIS, merge transformation.
No, sir, I don't know.
We did
Words.
merge,
Words.
Merge.
union
Merge
merge.
transformation.
Oh.
Merge transformation in SSIS. So, if you have two different similar sets, this will help you to sort, this will help you to merge, combine the data. Okay. So, I'll show you an example so that you'll understand. I have two different tables, employee US, employee India, and I have data in both tables. Now, what happens? Correct syntax. So if you see, I have two tables and having a same structure, correct? Same structure, two tables, and data types also same, integer, varchar. So now I want to combine these two tables. So how do you do? Union. So what is the first query? I'll write union all, let's say. First query is having EID, ename. Second is having EMPID, EMP name. Now I'm going with the first. So output will be EID, ename, not EMPID, EMP name. Got it?
Yes, sir.
So it is combining the two tables and it is taking the column heading from the first table and it is showing it. It is combining. So whatever the tables you are combining, they should have the same number of columns and the corresponding column should have the same data type. That is rule number one. Rule number two, it is going to combine the data and the output heading will be based on the very first query. Rule number three. What is the rule number three?
Order by.
Order by. Yeah, if you want to do order by, you cannot write order by that. Order by two, let's say order by ename, let's say. Just a moment. Okay, you just go through the points. It is a syntactically wrong. Okay, go through the points. Questions, please. Are you able to hear me?
Yes,
Yes, sir.
sir.
Yes. Yes. I think we're clear up until now.
Okay.
Yes.
Okay. Then let me go with the queries. So, all is used to combine the data from both the tables. All is used to combine the data from both the tables. All combine the data both along with duplicates. Union combines the data without duplicates. And also with union, data gets sorted by default. By default, data gets sorted. Intersect gets only common data between the tables. Except gets uncommon data with the top table. Only you'll get data from the top table, which is not presenting in the bottom table. Okay. So here, if you see table 1, table A, table B, union all, it will combine the data along with duplicates. Here, if you see 5 is a duplicate, it is showing 2 times. Union combines the data without duplicates. So this is table A, this is table B, this is a common data and it is getting without duplicates. Intersect gets the data which is common between the table A and B. Except A except B, 5 is common, so 5 will not come. Except B, 1, 2, 3, 4. B except A, 5 is common, 5 will not come, 6, 7, 8, 9. So this is except. When it comes to the data here, writing table, so union all, it combines data along with duplicates. See, it combines the data along with duplicates. No sorting. 1, 2, 3, 4, 1, 5. It came as it is. Union combines the data without duplicates. And also it sorts the data. You see here 1, 2, 3, 4, 5. It sorted the data. Intersect combines the data but only gets common data, which is common. See, Balu is only common data. Balu is only common data. Now, except which is there in table A but not in table B. Which is there in table A? 1, 2, 3. Here 1 is common, so 1 will not come, 2, 3 will come. Similarly, other way, okay. India except US. So this is having 4, 1, 5. This is having 1, 2, 3. 1 is common, so 1 will not come, 4, 5 will come. Are you clear about this?
Sure.
Clear,
I have one question.
Yes, please.
So why do we need this when everything is done by join?
Join won't do this, right? Having 10 columns. They will be having 6 columns. Correct? Table A having 10 columns, table B having 6 columns, and common column only 1. You will join and get the data. First question, rule number 1, it is not followed. All the column, same number of columns in the both table, not followed. Corresponding column should have data types, not followed. Correct? Still you can join the data. Yes or no? Let's say if I join these 2 tables, on what column you can join? On ID column, but values are matching. Only one value is matching. So what you'll get? You'll get only 1 row, but you'll get 4 columns. Yes or no?
Yes, sir.
Not 2 columns.
like
By
inner
default,
join.
you'll get 4 columns. So you got 4 columns when it is joining. But how we are getting here? 2 columns only, right? So join cannot be compared with set operators. The purpose of join is different. The purpose of set operations are different. The rules are different. Here the rules are, there should be a common column. Okay, here all the columns should be common. All the columns should have the same data type, correct?
So in join, like there should not be, So in join, like there will be no same column.
join one common column should be required. That's all, right? So now see customers table and branches table.
Oh, okay. Makes sense now.
So combining customer table, branches table, combining employee table, department table. Those are two different tables, but you are joining, correct? Two different data sets. Here similar data sets. Got it?